Hi guys, today we're going to talk about arc length, which is a little bit different than arc measure. Arc measure is in degrees, where arc length is actually if you put like a tape measure down on whatever part of the circle you wanted, how long is that part of the circle, in centimeters, inches, millimeters, whatever the case may be. So we're going to do a little bit of an investigation to start us off so you can see where this comes from. Starting off, we're going to talk about arc measures, the measure of central angles, and the measure of arcs. So if we wanted to find arc DE, that would be this arc measure, and that's in degrees. And we know DCE is 90 degrees. Because this is a central angle, that arc's measure would be 90 degrees as well. In this next example, we know that measure HCF, that's right here, is 120. And we are asked to actually find the arc measure that's the major arc, HDF. So that's all of this. So if this is 120, this arc right here would be 120, and this major arc would be all the way around the circle except for that 120, so this would be 240. And then finally, we know that DCH right here is 45 degrees, and we're just finding this minor arc HG that would also be 45 degrees. Okay? So in this next part, it says, hey, the diameter of the circle is 32 meters. What's the circumference? Well, hopefully you remember there are two formulas for circumference that we use. And you probably remember 2 pi r. Now, 2 radii is the same as the diameter, so the other circumference formula is pi times the diameter. Since we know the diameter of the circle is 32, then the circumference is 32 pi. And this is in meters. Okay? So now we're going to use that information down here in our investigation, and it says, hey, if we know that arc DE is 90 degrees, it asks us, what is the ratio of that circle then? Well, if that would be 90 over all the way around the circle is 360, so that would be 1/4 of the circle. And then if we had HDF, we found that measure to be 120, and that would represent same situation over the whole thing. That would be 1/3 of the circle. And then finally here we had HG, and that was that 45 degree arc. And what is the ratio of that arc compared to the whole thing? That would be 1/8 of the circle. So now the big idea is like, how do we use that information to figure out actually what is an arc length? Not an arc measure in degrees, but an arc length. So how we're going to do that is we're going to set up a ratio. We're going to say the arc measure, that arc measure over the whole circle. Arc measures in degrees, the whole circles also in degrees would be 360. That ratio will be equal to the arc length, and that's a measurement in inches, centimeters, whatever we're talking about. And that's going to be around the whole circle. It compares to the whole circle, like this is the degrees over the whole circle in degrees. Arc length, a measure in feet over, or inches or whatever, over the whole thing, which would be the circumference. All right. So then in our next little problem here, it says, use your thoughts from the above stuff to figure out the actual arc length of the major arc HDF. Well, HDF from above Oh, I screwed this up. Above, this should have been 240, right? HDF, yeah. So you guys aren't here to help me. This should have been 240, sorry. And then this would have been 240, and then this would have been 2/3. All right, well, what can I say? All right, so this would be, hey, how many degrees? It was 240 over all the way around is 360. We're trying to find the arc length of the circle, and we know from above that the circle had a circumference of 32 pi. And then you just solve that. So when you actually multiply diagonally, you get 7,680 pi over 360x. That's how you solve a proportion. And then your x is going to be 21 1/3. And if you left that as an improper fraction, that's fine with pi. And that would be approximately 67.021, and that is in meters. And I should have put meters up here if I had a chance. All right, if we did the same thing with HD, HD was 45 over the degrees over degrees, arc length over the circumference, which is all the way around. And then when we multiply diagonally, we get this. And if we were to solve this by dividing by 360 on both sides, then we would get 4 pi. And that is approximately 12.566. And that is meters. Okay, sorry for the long video, guys.